So this is how the UK government got the conclusion that millions of Britons will need to contrast coronavirus for herd immunity. And according to their conclusion, at least 60% of their population need to be infected by the virus for the herd to have herd immunity. It is a very simple model, and although there are more complicated models, the basic idea is the same. It's truly very basic calculation, and the most important thing is all the parameters and data are not tested and confirmed. This is truly amazing. Okay, so when a virus breaks out, there will be different groups of people in the population. There will be people who are susceptible, and there will be people who are immune to it. And what we want is immune people to be as many as possible, so the virus could stop spreading in the population. And we say the herd or the population have herd immunity if the immune people reach a certain level, so the virus could just stop spreading in the population. Yeah, we say the herd has herd immunity when this happens, okay? And we call the level of immune people in the population we want to reach the critical vaccination level. Okay, vaccination level, critical vaccination level. And VC is mainly affected by two factors. One is R0, we'll get to this later, and the other one is E. E is how effective the antibody is. Effective. And R0 means if one person is infected, how many people can this infected person get infected? And this is the relationship between R0 and VC, I'm sorry. So the more people one infected person can infect, the higher the critical vaccination level has to be, right? And this is the relationship between vaccination level, critical vaccination level, and E. E is effectiveness. Okay, now let's consider the easiest situation where the effectiveness of the antibody, E is 1. This is truly the easiest situation now. Okay, so in the population, VC people have the antibody, and 1 minus VC people don't have the antibody. This many people don't have the antibody, and they can infect this many people, right? We want this to be less than 1, so the virus does not spread anymore. You solve for VC, and you got okay. Now, WHO tells us R0 is in between how many? 2.2 to 2.7. So UK government took the median. 2.5. Okay. And you use R0, get back in here. So they want VC be bigger than 60%. Yep, that's how, so easy. That's how they got the number. So dumb. Okay, so this is what happens when we assume E equals 1. What if it's not 1? Easy. You just need it to be this actually. So if the effectiveness is higher, you need a smaller critical vaccination level. Now, problem number 1, R0. It's not necessarily this number, and new researchers will believe this is in the range from 3 to 6. If you use this range, VC is gonna be approximately like 67% to 83%. Means this many people have to be immune for the herd to have herd immunity. And problem number 2 is death rate. When we calculate this here, death rate is not taken into account. What does it mean? It means that some people may die before they, some people can, but they may just die before they have the immunity. So the final value for VC will be theoretically higher than this. And problem number 3, E. E is just not necessarily 1. Have you considered what's gonna happen if E is smaller than this? So when R0 is 6 and when E is smaller than this, no matter what value you take in this formula, you will have, which means even if 100% of the population is immune, it's not going to stop the virus from spreading. And problem number 4 is sequelae. There are researches showing that coronavirus, even if you're cured and now you're immune, there are sequelae like a weakened reproductive system. So yeah,